Hello and welcome. We are talking today about NASA's newest mission, GOLD. GOLD will be exploring our interface to space. I'm Karen Fox. I'm here today at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We will be taking your questions. You can put them in the comments down below or on the sides. You can also use hashtag AskNASA. We'll be answering your questions a little bit later on in the show. So we're talking today about space, and I don't mean the farthest reaches of space that Hubble takes pictures of. I'm actually talking about the very fabric of space between the planets, and today especially that space around Earth. Increasingly, this is the domain of humans. We have satellites traveling through there. We have radio communication waves traveling through there. And it's a really dynamic place. The upper atmosphere affects it, space weather affects it from above, and we need to understand it better, which is what GOLD will be helping us do. To talk a little bit more about that today, we have Richard Eastis.
Okay.
Richard Eastis is the person who conceived of the GOLD mission and has been watching it all the way through development. I want to start out just hearing a little bit about the beginnings. What was the journey? What were you inspired by? What was it that you wanted to study with this mission?
Well, what we wanted to do is get the big picture. We've been, for years, we've been studying the Earth's upper atmosphere, thermosphere, and ionosphere, we call it sometimes, and we've been looking at those in detail from the ground and from low Earth orbit missions. We wanted to be able to back off and look at it from geostationary orbit and get the big picture, get a whole hemisphere at once. That lets us put things into context, things that we can't understand when we're just looking at one little piece. And also at the same time, we wanted to get pictures of the temperature, which is something we've never had before. That's a unique piece of this mission. We'll get various pieces of information, some of which have been done before, but the temperature is something different. We'll get pictures of the temperature in the upper atmosphere. So that's what's really inspired us to do this. That's really where we headed when we started doing this. That's what we're trying to do.
So we're going to be getting a bigger picture, a more global scale picture than we've been able to get before. It's exciting stuff. I'd like to talk a little bit today about why that matters to us down on Earth, why this region of space actually affects us. And to focus on that, we're including Sarah Jones, who will be joining us. Sarah Jones is the mission scientist for GOLD here at NASA Goddard. Tell us a little bit more about why this region of space, this low level of space, affects us here.
Sure, Karen. You know what? Space isn't just the home of astronauts and where our satellites fly. It's actually a region that's very important to us. How about we take a look at this graphic? So the region that we're talking about today is the region of the upper atmosphere that starts around 60 miles above us and extends upward. And most of the gas up there is actually essentially an extension of the air that we breathe below. But there's actually a small component there that is created when the sun's radiation hits the gas in the atmosphere and breaks it apart into ions and electrons. And this new ionized component we refer to as the ionosphere. Now, the ionosphere has major impacts on the technology that we use today, in part because of the way that it affects the way that radio signals travel through our atmosphere. So, for example, we have radio signals from our communication satellites and from our GPS satellites passing down to the ground to our cell phones and GPS navigation systems that have to go through the ionosphere. And the ionosphere is a very dynamic place with a lot of structuring. And as the structure develops, it can actually garble all of these signals that are coming through our atmosphere. It's more variable than we had realized in the past. And it's actually an exciting opportunity for GOLD to now take a look and help us to understand how the ionosphere affects our day-to-day life.
Thank you very much. If you're just tuning in, we are here today talking about NASA's newest mission, GOLD. It's going to be launching at the end of July from French Guiana. It is a mission that has been led by the University of Central Florida in Orlando, Florida, and the instrument itself was built at the University of Colorado, the Laboratory of Atmospheric and Space Physics. We are taking your questions today. You have lots of time to send them in. Use hashtag AskNASA or put them in the comments below and we will answer them. We actually have our first question already, so I'm going to ask you, Sarah, for this. The question we have in is, I'm almost there. The question is, I thought space was a vacuum. Tell us how we can actually study that.
Okay. Well, space is actually a vacuum, that's true. But actually, the vacuum of space is not completely empty. In space, we have particles. For example, there's energetic particles that are moving quickly through space, and there are electric and magnetic fields which kind of guide the way that those particles move through space. And also in our ionosphere, we have these same particles and fields that are kind of determining how the Earth interacts with the space environment around us.
Richard, do you want to add anything to answer this question? We have anything about gold that we want to know about space for this?
Well, I think space certainly has a lot of influence on on what the systems we use day to day, and also it's sort of tells us a lot about what is happening to other planets. Earth is our closest planet. We're able to look at it and learn from it that things that we can't easily learn from other planets because they're too far away or too difficult to study.
Right, so the space matters. This stuff around it, it's not completely empty. There's stuff going on in there, and it helps us understand a lot about our solar system. All right. With that, let's focus a little bit more, Sarah. Tell us specifically what GOLD will be trying to learn.
Sure. The GOLD mission is studying what's essentially a new area of scientific research that has opened up recently. In the past, people thought that this region of the Earth's upper atmosphere was affected primarily by what's happening at the sun and what's coming to the Earth from the sun. So, for example, we have an image here of the sun's radiation coming down and hitting the Earth's atmosphere. The sun's magnetic field also interacts with the Earth and causes things like geomagnetic storms and other effects that we refer to as space weather. However, in about the last 10 years or so, there's been this growing body of evidence that the upper atmosphere is also affected by what's going on below, like the terrestrial weather, which is the weather that we experience every day here on Earth. So, for example, tsunamis create waves in the air, and those waves move upwards. And the waves could potentially cause changes even at the very boundary between the Earth and space. And so GOLD is studying in particular how to tease out the effects coming from the sun above and the Earth below. And NASA actually has 2 upcoming missions studying this sort of science. One is called ICON, and the other, of course, is GOLD that we're talking about here today.
So we learned a little bit here about what GOLD specifically will be studying. That's what we're talking about today, our new mission GOLD, to study the lowest reaches of space. Another sort of interesting thing about GOLD, we'll be talking about it more as we go on, is that this is actually the first time NASA has put a mission like this onto a commercial satellite. So we'll be hearing a little more about that as we go on. But in the meantime, let's talk again to Richard Eastis coming on to discuss what are you going to do with this information. So there you are, you get all these great observations. What happens next?
Well, the data will be taking these pictures and using them to help us understand pieces, basically help us piece the puzzle together. It's a big piece of the puzzle we haven't had before, so this global context. And it'll also help us put other pieces of the puzzle that we already have and just don't know where they fit. It'll help us understand where those fit together, how it all fits together. So we'll use what we learn, to develop better models of the upper atmosphere. We have some really good models now, but we know they're not adequate. We know that they fail in a limited time frame. Just a day or so we can't go out very far in predicting what's going to happen. So what we plan to do with this is use those to help us improve the models and improve our understanding. Thanks,
fantastic. So here you are. Today we are talking about our newest mission, GOLD. I'm standing here right now at NASA Goddard in Greenbelt, Maryland. We are taking your questions. We're going to be answering them throughout the show. So please go ahead and put them in the comments. You can use #AskNASA. We will be tracking them. We've been talking about this region of space, and we've been talking about how dynamic it is, but I want to give you a bit more of a tour, really give you a sense of geographical location and what is going on there. And we have a special movie for everybody to look at, so we can roll that next.
Longing for more space, open skies, and exotic travel? Then look up, about 30 to 600 miles straight up at the ionosphere, Earth's interface to space. Nestled far above the clouds but below outer space, this little understood destination invites you to explore its many features. Experience both the weather from Earth and the weather from space. Marvel at the ballet of radio waves and navigation signals, like GPS, leaping through this particle paradise. Sit back, relax, and take in the aurora, some satellites, and the International Space Station as they sail by. And you'll want your camera handy for one of the region's signature features, bright and colorful air glow. This daily show is made possible by the ionosphere's own swarming charged particles, because that's what the ionosphere is. It's all charged particles.
Hello and welcome back. We are here today at NASA Goddard talking about NASA's newest mission, GOLD, which will be studying that region of space you just heard about, the ionosphere. I have with me Alex Young, who is a heliophysicist here at NASA Goddard, and he's going to give us a little more explanation. How does this ionosphere fit into the bigger picture that NASA is studying about space?
Yeah, so let's talk about what is heliophysics. So studying the ionosphere is part of this bigger area called heliophysics, and heliophysics is centered around the sun, but it's much more than just the study of the sun. So we've got a diagram here that's showing you all of the energy, light, matter, and magnetic and electric fields that are coming off of the sun, filling the solar system. And here is showing them interacting with the Earth, but they in fact interact with every part of the solar system, every planet, every object. And this all creates a great system that we call the heliosphere. And so studying the ionosphere is one of those parts of this bigger system. Understanding this tells us about the fundamental processes that are happening on many different scales, from the smallest scales to the particles in the fields, all the way to the size of the planets and the sun itself. And all of this creates this dynamic space that we're talking about, and this is what makes this non-empty space. It's all of the stuff coming off the sun interacting with everything in the solar system. And the reason that it's really important is not only is it telling us about fundamental science, which is pertinent not just to what happens here in our solar system, but in fact other solar systems, exoplanet systems, but also all of this energy and matter interacts with our technology. So as Richard and Sarah have mentioned, this interacts with our technology when we talk about the ionosphere. And in fact, even farther out in the magnetosphere of the Earth, or even in the broadest parts of the heliosphere, all this stuff and all of this non-empty space is messing with technology. It's interacting with spacecraft, sometimes disrupting them, and it even creates a really nasty environment for astronauts. So understanding that is important also for space travel near the Earth and through the rest of the solar system. So that's the bigger picture of heliophysics.
So with that, I have a good question for you that we got in. We are taking your questions. You can use hashtag AskNASA. We have a perfect one that segues right into this. And the question is, Jay from Facebook asks, how do the results of this mission contribute to space weather prediction?
Well, that's a great question because, and even Sarah and Richard both hinted at this, understanding this interaction is telling us about the fundamental physics, interactions of plasmas, which are this ionized gas, also with neutral gases. That actually happens in many different environments throughout the solar system, even on the sun itself. So that fundamental physics is really important, but it tells us about how our technology, how radio waves interact with this ever-changing atmosphere. So understanding this is really critical for us as we continue to expand all the technology that we use in our society. And understanding this atmosphere tells us about other atmospheres, other planets in our solar system, and exoplanets.
Fantastic. We have some more questions that we will be taking right now. I'm going to throw this one to Richard. Welcome back.
Yeah. Good to be back.
This one is from Kevin from Facebook. Is there anything in particular we are looking for in this mission, something specific, or is it just more of a general understanding of the region?
Well, one of the things we're looking for is for years we've had information about the oxygen and nitrogen, about the composition of the upper atmosphere. We haven't had really images of, we have images of those, but we haven't had images of the temperature. And the combination of those two is what makes is really so useful to us, because those are really key pieces of understanding the puzzle of the upper atmosphere. And we have both of those. That's really what the thrust of this is to look at the interaction between those, see how those change over time, and be able to watch them throughout a day to see how it evolves, because our previous missions have either been very limited in the location they could cover, or they have been very limited in the amount of time coverage they could provide us. And we know that the upper atmosphere changes on the order of an hour, has really large changes in the order of an hour, but we've only been able to revisit at the cadence of several hours previously from satellites. So that's really the thrust of the key piece of what the mission's doing.
Thank you. We are getting lots of questions in, and we are going to keep answering them throughout the show. But we're going to take a break now to move on to something else very interesting about gold. I mentioned earlier that this is it is the first time that NASA has a mission up on a commercial satellite. And to talk a little bit more about that, we have Todd Gossett, who is joining us. He is here from SES Government Solutions.
Thank you, Karen.
Welcome. So what gold is what's called a hosted payload, and Todd is in charge of hosted payloads. So tell us a little bit about that. How are we catching this ride?
Okay, well, first of all, I want to explain just a little bit about what a hosted payload is. It's a piece of space hardware, it's a mission, as you were, that has a function, a purpose, maybe an operating organization that is distinct and different from that of the host spacecraft. So for SES-14 and Gold is operated by University of Colorado on behalf of NASA. It's doing the science mission. SES-14 is owned and operated by SES. We're providing C and KU band communications over the Americas, over the transatlantic region with that satellite. So separate and complete missions. Further, why use these? Well, a company like SES, which owns and operates dozens of satellites, we have to sustain that fleet, and we do that by procuring and launching on average of about 3 satellites per year. Each of those satellites affords a ride share opportunity, a hitching a ride opportunity for a hosted payload, as we're able to, most of the time, provide excess size, weight, and power, that real estate on board a spacecraft, to a hosted payload customer. And further, a hosted payload customer can also take advantage of our infrastructure, the ground centers that we have set up to command and control the satellite, the communication services, the fiber, the ground stations that we use to move data around on behalf of our satellite communications customers, etc. What does all this mean? Well, a hosted payload customer can oftentimes use a hosted payload to save tons of money, up to hundreds of $millions versus procuring a dedicated satellite on their own.
Fantastic. Tell me a little bit more about how we even get that instrument up into space coordinated with SES. I said before, sorry to interrupt you. I said before that the University of Central Florida is the lead institution, and it was built at the University of Colorado's LASP laboratory. So from there, it has to get all the way up into space, and maybe you can walk us through that process. I just realized I have one other important thing to say, and I've cut you off again, and I'm sorry, but I want to say thank you to our live stream watchers. We have actually just gotten our stream up on Facebook, and I really appreciate you guys sticking with us, and welcome, and stick with us. We've got interesting stuff to talk about today. And now, back to you, Todd.
Okay, so we left off University of Colorado, Laboratory for Atmospheric and Space Physics, built the Gold payload. They finished it up around the end of 2016, and they shipped it to Toulouse, France, to the Airbus facility. Now, as an aside, Airbus is our contractor for SES-14. They built the satellite for us. Also, they integrated the Gold hosted payload onto SES-14 in April of last year. And I think I've got a graphic here. This is an artist's depiction, but this shows Gold, the instrument on top of the nadir deck, surrounded completely by SES-14's mission, which is communications. So that's how it got there. Throughout the spring and summer and into the fall, the satellite underwent what we call assembly, integration, and test in Toulouse. That basically finishes construction of the satellite and also tests it out to make sure it meets our requirements. Not only do we make sure we meet our requirements, but there's a compatibility testing that goes on as a part of this, where we made sure that SES-14 would do no harm to the Gold mission, and vice versa, that Gold would do no harm to the SES-14 mission. We finished all that up in the fall, and the satellite was packed up and transported to Kourou, French Guiana, in December. And I think we have a graphic real quick to show where Kourou, French Guiana is. This is the location of the Guiana Space Center, which is where Arianespace, which is a European company, launches their satellites from, launches their rockets from, and this is the launch infrastructure here to the northwest of Kourou. Satellite was packed up and transported, like I said, on the 22nd December, arrived in Kourou. As you can see here, it's being unloaded from the Antonov aircraft, which we contract to move our satellites around. And it's currently being processed in Kourou for a January 25th launch on an Ariane 5 rocket.
Fantastic. And then what happens next? It goes into space.
Exactly. January 25th, the launch occurs, and the Ariane 5 will give SES-14 and Gold a ride to what we call a transfer orbit. And over the next few months, that orbit will be increasingly raised up to its geostationary spot. Its final geostationary spot is going to be at 47.5 degrees west over Brazil, in which it'll do that satellite communications mission that I mentioned earlier. But even of more interest to us today is that's when we turn Gold on and put it through its commissioning process, so it'll start its mission for the next couple of years.
So let's talk about that a little bit more, because one of the things that's so fascinating about a collaboration like this is that you need to have an orbit that works both for this telecom satellite and for the mission itself, for the mission to do its science, right? So,
Yes.
so transfer into that. Tell me what Gold can do. Why does this orbit work for Gold? Why does it want to be there?
Okay, well, the great thing about this orbit is geostationary orbit stays above one location on Earth, and that allows us to keep reviewing the same locations on Earth over and over. We're planning to do this a half-hour cadence, as we mentioned earlier, I think, and that lets us follow the evolution in time throughout the day of the upper atmosphere. Previous missions from low Earth orbit, we have difficulty, or actually we can't tell between changes in time and changes in locations. Since we're revisiting different locations throughout the day and at different times, we don't know which is really the source of the change. And we know that both those things influence what we're observing. So that's the really great thing about Gold. And also it's far enough away, it lets us view a hemisphere, gets us a large-scale, global-scale view from the instrument. So.
Let's follow up on this. We have a good question that's come in. This is from Kimberly Underwood.
Okay.
And they're asking, how did the launching on a commercial satellite come about for Gold? How did that even happen? I know you guys have been talking to SES for a while.
Yeah,
Can you tell us
yeah.
a little bit about some of the initial conversation in the spark there?
Well, okay, the initial conversation was, I was looking for a ride, actually, and I called up a few satellite companies looking to see who's willing to, who has satellites and who's flying them, and I realized that communications companies are flying lots of satellites. That was a place to go. So we started talking to some of the communications satellites companies, including SES, and it evolved from there. And they were very helpful, really great to work with. It's been a really good experience for all of us.
That's great. We are continuing to take your questions. We are here at NASA Goddard talking about Gold, the newest mission launching in January from French Guiana. And in addition to taking your questions, we are continuing to talk about what Gold can do. You just gave us this information about what it can do from its orbit. Can you tell us just a little bit about the instrument? How is it scanning? What is it seeing? What's going on there?
Okay. Well, what it's doing is it scans, it's like a spectrograph, so it actually separates the different wavelengths of light out, different colors of light out, and by using the differences in how the colors change over time and how what they look like as far as the colors, we can tell what the composition of the upper atmosphere is, how it changes. We can also tell what the temperature of the atmosphere is doing, and at night, actually, we can see the nighttime air glow, so we can see the structure in the air glow, and we'll see the structure in the daytime too. So it scans across the Earth in half-an-hour cadence, and by combining those individual pictures as we go across, we get a picture of the whole Earth at that cadence. So we can use that to tell us what the temperature and give us pictures of the temperature and composition and other information about the upper atmosphere.
So this is one of the things that I find particularly interesting. You're talking about these 30-minute scans of the entire disk, but it can be flexible too, right? It can zoom in, it can do faster scans. One of the things that's so useful about that is we can coordinate with other missions and other things that are looking at the ionosphere. And Sarah Jones recently mentioned at the beginning of this show that we have another mission coming up this year, later in 2018. It's called the Ionospheric Connection Explorer, or ICON. Tell us more about that. How can these two play together?
Sure. Well, the ICON mission is launching later this year. And it consists of a suite of instruments that will be flying in low Earth orbit, studying a science that's very similar to what GOLD is studying, but of course from a different vantage point. Low Earth orbit is the type of orbit that the ISS flies in, and this is right within the upper atmosphere that we've been talking about. So ICON will be flying through that very region, directly measuring the particles there and how they move. That means the ICON will be getting a very localized view with fine scales, in contrast with GOLD, which is hovering 22,000 miles above, seeing the whole global scale and watching everything play out below. So these two missions are very, very complementary, and they'll give scientists a more comprehensive picture of what's going on here, from the global scales all the way down to meter scales. Now, Karen mentioned that ICON is an Explorer mission, and that's actually part of the Explorer line of missions. Do you want to talk about that, Alex?
Yeah, so that's a really cool line that NASA has, the Explorer program, and it is both missions that have their own dedicated spacecraft or what's called a mission of opportunity like GOLD, where in this case we've actually for the first time have it on a private spacecraft. And the cool thing about Explorer missions is they're designed to be very nimble, very quick to come around, relatively low cost, but specifically they're designed to answer very specific questions, very focused scientific questions. And so they're a very important part of the line of missions that NASA has in heliophysics and actually also in astrophysics. And all of these different missions are addressing different parts of kind of the bigger piece, as we talked about before, of the puzzle of all the different things that are happening in the heliophysics system.
Thank you guys so much. I'm really enjoying this today. We are taking your questions. We are getting so many questions about the collaboration with the commercial satellite, and I promise you we're going to get to those. There's some good ones coming in. In the meantime, you can keep asking questions by using the hashtag AskNASA. I have a couple of questions now. I've got a nice, easy one for you, Richard.
Okay.
What does the limb and disk part of the title mean?
Okay, the disk is looking down at the Earth, sort of the most of the Earth that you're seeing. The limb is just the horizon, the sort of the edge of the Earth when you're in geostationary orbit, or actually can be not at geostationary orbit, you still see the limb. So that's the difference. The limb is where all we're seeing there is we see up in the atmosphere. We can look at stellar occultations, we can look at altitude profiles of emissions, but the disk is where we get actually sort of pictures of what's happening on Earth.
All right. Also getting a question from Jane on Instagram, who asks, will GOLD be able to detect the effects of solar flares?
Oh yes, definitely.
Oh yes, yay.
Yeah. The air glow that we're looking at that's responsible, and the nighttime air glow or the daytime air glow both respond to what's happening in the sun. So the solar flares will influence those. We'll see very quickly the daytime air glow. We'll see the changes.
Can I add to that, actually? So that's actually really cool. It's really exciting. We've had a lot of really nice discoveries recently. You know, we see oscillations in solar flares. We see that in the X-ray light that comes from the sun. And recently, for the first time, we've started to see those corresponding oscillations directly connected in the ionosphere. So having more observations of the ionosphere is really, really cool for seeing this Sun-Earth connection in a new way.
That's exciting. One more now, though you can keep asking questions by saying Ask NASA in your hashtag or including it in the comments below. Again, we are talking from NASA Goddard about GOLD, NASA's mission which will be launching at the end of January to study the interface to space, the boundary to space. This overlaps with the upper atmosphere. We've talked about how it's also going to take into consideration terrestrial weather. So we have one last question for this round, and that's Alex from Twitter, who would like to know, will GOLD improve weather forecasting on Earth?
I don't think, as far as we know, it will not improve weather forecasting on Earth. But the weather forecasting on Earth we can use that to improve the weather forecasting in space. That's the way it's going to work.
All right, fantastic. I'm going to ask some questions now. It's my turn. All right, what I want to know is, Richard, what is the thing you're most excited about? You've been with this mission for a long time. It's about to launch. What are you most excited about?
I think getting data. That's after working on this for several years. I won't go into how many. It's exciting to get data. I think it's also interesting to get, as fundamental a parameter, as fundamental a piece of information as temperature is. We've never had pictures of the temperature in the upper atmosphere, and that's it's just as important. Just because you know the temperature in California doesn't mean you know the temperature in D.C. It's just as important in the upper atmosphere to understand what those temperature differences are, and we will finally have that. So I'm looking forward to that.
Fantastic. Everybody's going to get their turn here, so get ready for your answers. Sarah, what is the thing that is most exciting for you about this mission?
Okay, well, one of the things that I'm excited about is this opportunity that we talked about for the GOLD and ICON missions to work together, and being able to, for the first time, get a really global scale view and a fine scale local view at the same time. And like Richard said, much faster than we ever have before, like getting a picture of the global scale every 30 minutes. And that's really going to let us look at day-to-day effects in addition to the longer-term effects that we looked at in the past.
All right. That brings us to Alex Young. What are you most looking forward to? What are you most excited about with this mission?
Well, I'm excited. Actually, it's kind of an extension of what Sarah said. So the cool thing about the combo between ICON and GOLD is the fact that we're getting this global view that's actually remote sensing, and then we have the in situ view. We're actually sending something through it, so that's ICON flying through it. And that's one of the most important ways that we have to do heliophysics. We have all these different places in the solar system, in the heliosphere, and we have some spacecraft that are looking at a distance. They're giving us this remote sensing view, and some where we're actually flying spacecraft through it to basically scoop up particles. And that is part of the bigger heliophysics fleet. So these two missions, GOLD and ICON, are actually part of this bigger picture. So we have this graphic here that's showing all of the different missions of what we call the heliophysics fleet, or even the Great Heliophysics Observatory, because really all these different missions are part of one giant observatory. And they're showing us the sun, both inside and out, all of the stuff that is creating this space, and then they're showing all these different environments. The ionospheres we've talked about, moving farther out, the magnetosphere of the Earth, the magnetospheres and ionospheres of other planets, which can be vastly different, and how all these things interact, as well as the broadest regions of our local space to the very edge, with even spacecraft like Voyager, which have now flown outside of our solar system and are starting to touch interstellar matter, interstellar medium. So that, to me, seeing all these different viewpoints and pieces come together to give us that global scale view is really what's so exciting.
Fantastic. And last but not least, we have Todd Gossett from SES Government Solutions to tell us what he finds most interesting about the upcoming, not interesting, most exciting about the upcoming GOLD launch in January from French Guiana.
Well, Karen, what I'm most excited about, and SES is most excited about, is getting SES-14 with a hosted payload, this partnership that we have with NASA, into orbit finally. Hardware in space is awesome. SES has been working with Richard and the GOLD team for the good part of a decade, dozens of people company-wide, and now we finally get to realize the fruits of that labor and demonstrate this commercial partnership with the U.S. government.
Fantastic. It's going to be an exciting mission. We have a bunch more questions, and we're going to start going through them. I'm going to keep you guys up here, and we will ask each of you the appropriate questions. Again, you can still leave them for us. Use the hashtag AskNASA or down below. We are talking about this interesting region of space. If you have questions about the science there, what's going on, or questions about the mission, we're interested in hearing them. A whole bunch. We have a number from some of our press who are watching as well, so we will go through this. We have from Spaceflight Insider, what does NASA hope to gain from hosting a mission aboard a commercial satellite?
Well, NASA's really excited about the success of the GOLD mission and how it's been working out. And so I think that Richard and Todd really talked about what we're gaining in that case. Now, not every mission can be a hosted payload. Some missions need a special customized bus. Others don't. Others could potentially fly as hosted payloads. And so I think exploring that space and those options that we have for getting our instruments into space is something that we're really excited about and that we hope to do more.
Fantastic. All right, we also have, I'm going to give this one to you, Richard. This is from Jean from Twitter.
Okay.
Why couldn't Gold just have been mounted on the International Space Station instead of going on a commercial satellite?
Good question. The International Space Station, of course, is in low Earth orbit, so it goes around, it has about a 90-minute orbit, so it doesn't allow us to stay in over one location and keep looking. And also, it's so close to the Earth that we don't get as big a view, as wide a view as we do from geostationary orbit. So that's the reason we wanted to go to geostationary orbit.
Remind us how high Gold is going to be in its geostationary orbit.
I think it's about 22,000 miles is what it is, so it's quite a ways out there. So that gives us the perspective that we were looking for. You can see almost half the Earth. Essentially, you can see half the Earth from there.
Fantastic. Finding some more, because there are a lot. This one I will hand off to Todd. What is the actual launch vehicle?
It's an Ariane 5. It's a vehicle provided by a European company called Arianespace. It's spelled Ariane, A-R-I-A-N-E, space, Arianespace. And their launch facility is the Guyana Space Center in Kourou that we showed earlier.
I'm going to ask you one more question. This is from Kendall Russell via satellite. What's the benefit for SES?
Well, the benefit for SES is my part of SES Government Solutions. We strictly do business with the U.S. government. This is another line of business that we've been developing for several years. It's obviously a source of revenue for the company, but it also extends our partnership with the U.S. government beyond just communication services and gets us into new and interesting areas that could be of potential benefit to the United States and its partners around the world.
Thank you. Carolyn from Twitter asks, will airlines benefit from the Gold and Icon missions? I'm going to start with you on that one, Sarah, unless you want to toss it to someone else.
I was going to toss it to Ellen.
I had a feeling you were going to do that. Absolutely, because as was shown in some of the diagrams and animations that Sarah showed and what both Sarah and Richard have talked about, the ionosphere has a huge influence on radio communications, both signals that are going through the ionosphere as well as signals that we use the ionosphere to bend to travel around the Earth. I mean, that, for example, shortwave radio, that's how we can communicate around the Earth. Using the ionosphere is like a lens. And so when the ionosphere changes and gets disrupted, it changes the way those signals propagate through and around it. And that directly affects airlines. In fact, it also affects certain wave bands that are used by navigation for ships. So it has a huge importance for aviation industry, for the maritime industry, and even for the military, because they want to be certain that their signals are going to get through, that they're always in communication. And so understanding the ionosphere, being able to enrich and improve our models, which are telling us what's happening over a longer time scale, is really critical. So ICON and GOLD are crucial components to really flushing that out and better understanding how this is going to be impacted.
This is part of what we've been talking about, right?
Yeah, and I'll add that FAA is going to a system where they use GPS to basically help them, manage planes in flight. And as they transition to that, if there's times when they can't be sure they can rely on the GPS signals, that they're going to have to go back to spacing for planes further apart, someone's going to get delayed sitting on the ground. So of course sometimes that'll be necessary, but sometimes if we don't know enough, that would be unnecessary, and people will be delayed unnecessarily. So it'll eventually feed into that with NOAA and the FAA.
All right. We're still going. We got a lot of good questions. You can still ask them. Hashtag Ask NASA. We're still going here. Next one is Cole from Facebook. He wants to know, How will gold measurements be affected by the solar cycle? Could the data be interesting during the quiet period of solar minimum?
Well, absolutely. The data will be interesting always. Let me just tell you that. But yeah, actually, there are certain scientific phenomenon that are more present during solar minimum, I think. Isn't that right, Richard?
Yes,
and we'll
correct.
be able to see that. And so looking at the upper atmosphere, both during these dynamic active times and also seeing the quiet times so that we can get a baseline understanding of how the atmosphere is behaving is actually really important.
Yeah, and I can sort of add to that. I mean, it is the case that, in some ways, we're expecting this to be a relatively low solar minimum. The previous solar minimum was lower than the one before that, and this is actually an opportunity to study, a state of the sun and a state of what's coming off the sun in a way that we couldn't before. We've certainly learned over the past 10, 20 years that space weather is not just these giant super explosions that happen, but in fact it's the subtle flows and fluctuations that are happening on the sun. And so we really need to understand them during times of solar minimum, not just times of solar maximum.
Yeah, and I'll add that during solar minimum, according to the models as we understand them, say that some of the stuff from the lower atmosphere will be more of an impact, be easier to see. So it's a benefit to us, where the signals are overall maybe less, that actually some of those signals will be greater. So
it's pretty exciting.
Yeah.
And just from being studying space weather in general, a lot of people have always thought, well, solar minimum is going to be boring for you. There's not going to be all these flares and CMEs happening. But that's actually not the case. It's another time to study things that we couldn't before, and to all times of the cycle are important. They all matter. They all have different effects, and we really have to understand them all to really see the big picture.
Next one is for me. I'm going to answer it. It's Ryan from Facebook who wants to know how we can watch the launch. And the answer is right here on NASA TV. We will be working with SES and Ariane to make sure we get Ariane Space to make sure we get some of that feed. You'll be able to watch it, and we will have information leading up to the launch as well, talking about gold a little bit more. So please join us for all of that. Keep asking your questions below in the comments or using hashtag AskNASA. A question for Richard. Mason from Facebook asks, how long will it take after launch to get data, and will it be publicly available?
Okay, the data will be publicly available. It takes some time for it to get into orbit, though, since we're doing the orbit, as Todd mentioned earlier, it's put into a geostationary transfer orbit initially. From there, it has to do a transfer to a geostationary orbit, and also the satellite has to be checked out. So it'll be, as we understand it now, the scheduled now, October, end of September, beginning of October, before the data starts flowing from the gold instrument. And it'll be able to take the science team about a month to check out the data to make sure that they understand it, that the good data is all good, that we've interpreted things correctly. So that's about the time we'll be getting. It will be available. We'll have it available through a website at UCF, and also be available on the Space Physics Data Facility, SPDF. It's NASA's site that has it also.
Great, looking forward to that. We are running out of questions, so if you want your question asked, put it in there, hashtag AskNASA, or put it in the comments below. We are still talking about NASA's newest gold mission that will be looking at the interface to space, the boundary between our upper atmosphere and space, an area that we care about at NASA because we've got a lot of stuff going on in there, our radio signals, our satellites, and it matters to us down on Earth. You have a question? Okay, I won't ask pilots. I'll ask pilots later.
Yeah, ask pilots in a second. But I have a question maybe for these two. Probably it was brought up in terms of when Gold and ICON would be launched, if they would be around for the eclipse, the big total solar eclipse we just had. But since that's not the case, and we do know that eclipses have an impact on the ionosphere, which maybe we'll talk about. So my question to the two of you, have you been sort of approached by any other eclipse physicists about future eclipses and maybe would they get data during another total solar eclipse that you guys might be able to use?
I'm glad you asked that. I really am. Because we've already looked to see when there's going to be other eclipses, and there's going to be one or two during the prime mission over South America. So not only do we get an eclipse, I have an excuse to go to South America.
Oh,
perhaps.
so you're going to, so for the 2019 and 2020 eclipses?
Yes, yes.
Oh, fantastic.
So we've already, but certainly if someone who's interested in science of eclipses is interested in this data, we'll be glad to talk to you, because we'll need to do some planning for the observations to make sure we look at the things that are most productive for us to look at.
Right.
Because as Karen mentioned earlier, the instrument can focus on a specific area. So during an eclipse, we would have at least one of the two channels, because there's two channels, at least one, maybe both, concentrate on the area where the eclipse is occurring.
Well, that's really exciting.
Yeah.
Because actually, during this past eclipse, we saw evidence of these waves propagating into South America from North America. So you possibly would have seen it.
Yes.
Some effect from it. So that's really cool.
Yeah.
Oh,
Yeah.
That's cool.
That is exciting. A lot to look forward to with this mission. I'm now getting back to Violet, because I promised I would do Violet.
Yep.
Violet from Twitter. If you're looking from a bird's eye view, how do you tell the difference between the upper part of the atmosphere and the lower part of the atmosphere?
That's actually a fantastic question, right? I mean, when I look at the atmosphere, it looks clear or it looks blue. But when we're looking down from above, actually, certain parts of the atmosphere are composed of different gases like hydrogen, oxygen, nitrogen. And when they get hit by the sun's radiation, they glow in different colors, actually. So certain colors will be dominant at certain altitudes. And that's how you can tell essentially what altitude you're looking at with a camera that's looking down. Now, gold is actually looking at far ultraviolet light, which is light that our eyes can't see. But it's the same situation there. There are certain altitudes that preferentially emit that far ultraviolet light.
And also, I'll add that far ultraviolet light is absorbed in our lower atmosphere. So we know all the light we're getting is from above about 60 miles.
That's right. Mm-hmm.
So we, sort of by excluding all that stuff down low, not being able to see it, then we know we're seeing the upper atmosphere.
Mm-hmm.
A question from Mark Gotch with Historical Aerospace News. How will Gold's imaging spectrograph view the ionosphere differently than previous instrumentation?
Okay, well, the way the Gold instrument was looking at it, it'll use some of the same emissions and some of the same processes. So we're looking at at night, there's atomic oxygen that's formed during the daytime. It recombines, produces oxygen emissions. But the thing that's different about Gold is we'll be able to sit and watch it for hours to see how the ionosphere evolves. We'll be able to watch the structures move in the ionosphere. We'll see the structures change. So that's what will be different about Gold, is the viewpoint we have of it and how we're able to follow the changes, and also follow the changes from what happened in the daytime to over to what happened at night. See how that impacts things, how it changes things.
We have one more question. This is from Jeff Faust with Space News, and it is specifically for Todd Gossett. The question is, what lessons learned for SES will they apply to future hosted payloads, whether it's for NASA or other U.S. government customers?
Oh, anytime we do this is our third at SESGS and the fifth at SES overall. And every time we go through the process, we learn a little something on how to take that process and apply it forward. Whether that's how to coordinate schedules, it's how to bundle requirements early on in the satellite procurement process, it's how to synchronize contracts, it's a whole host of things. How better to be a good steward of the taxpayers' money, how to communicate with the customer, et cetera. We learn something every time.
This has been great. I've had a really good time talking to you guys. It's been wonderful to get the questions from you, our watchers. Thank you so much for being here. Keep watching for more information about Gold, which, as we have said, is launching at the end of January from French Guiana. There will be more information on NASA TV and at nasa.gov. Thank you so much. Bye.